All right, so let's work through this second proof. If you don't have the first proof, we did that on Friday. You can watch Friday's video to get caught up on that piece. We're going to finish out our 3-6 notes packet today, and that gives us tomorrow to begin reviewing for your test on Thursday. What should this very first statement be? Our given information. So angle 1 is congruent to angle 2. My reason for that? It's given. Looking at the picture, are there any other angles that we could say are congruent? Two and 4 are congruent. Anything else? 1 and 3 are congruent. So angle 2 is congruent to angle 4. And angle 1 is congruent to angle 3. What are we using to be able to say that? How did you know they were the same size as each other? How did you know 2 was the same size as 4 and 1 was the same size as 3? What did you say? We don't have segments here. Vertical angle theorem. Notice these are across from each other, and all they have in common is that vertex. They don't share any sides. So this is my vertical angle theorem. Well, if I know that 1 is congruent to 2 and 2 is congruent to 4, what else could I say? 1 is the same size as 2 and 2 is the same size as 4. Yeah. 1 would have to be congruent to 4. What did we just use to be able to do that? Notice I have congruent symbols here. I can't use substitution when I have congruent symbols. So what could I use to say, since I know that 1 is congruent to 2 and 2 is congruent to 4, that means I can replace 1 with 4. What could I use here since I can't use substitution? What'd you say? Transitive property. Transitive property right there. Do I know anything that is the same size as angle 1? Angle 3. Here's the thing about the transitive property, though. The thing, like this piece right here, angle 2, that middle piece, it has to be at the end of the first one, so I see the first and the second, and then second and third object. So 1 is congruent to 2, 2 is congruent to 4, so I can say the first one and the third one are congruent. Here I have 1 is congruent to 3, but here I have 2 is congruent to 3. If I want to use the transitive property, I'm going to have to take this and turn it around the other way. Symmetric property. Angle 3 is congruent to angle 1 using the symmetric property. So if I know angle 3 is congruent to 1 and angle 1 is congruent to 4, what could I say? Angle 3 is congruent to angle 4, And why can we say that? Close. Remember, with congruent signs, I can't use substitution. Transitive property. Vertical angle theorem tells me that angles are congruent. All right, let's go ahead and flip this over and do another proof. Let's do number 3. Oh, there's a lot going on in that picture. Let's ignore the picture for just a second. What should I put as my very first statement? Absolutely. Angle ABE and angle DBC are right angles. My reason for that is absolutely because it was given to us. Well, what does it mean for angles to be right angles? They equal 90 degrees, right? Yep. So angle ABE is 90 degrees. The measurement of angle ABE is 90 degrees. Can I make that same type of statement about anything else? DBC, the measurement of angle DBC is equal to 90 degrees. What did we use to be able to say that? They told us that they were right angles, and we said, I know that means they equal 90 degrees. Definition of right angles. Nice work. All right, so let's see what we can do with that now. If I know that angle ABE is equal to 90, and I know that DBC is equal to 90, what else could I say? We're going to use the transitive property. What will transitive property allow me to say about this? Equals the measurement of angle DBC, yes. Because I have an equal sign here, I can use transitive property, or I can use what? Not symmetric, that allows me to just switch it around. Substitution. I can use transitive property with congruent signs or equal signs. I can only use substitution with equal signs. So transitive property or you could use the substitution property here. What are we supposed to be proving in this problem? ABD is equal to EBC. Well, ABD is right here. And EBC is down here. So I'm going to look at my picture to see if I can kind of find my way forward. We just made statements about ABE. Well, ABE is this angle right here. And we know it's how big? It's 90. So for just a moment, I'm going to pretend like I can't see this down here at all. Don't scratch it out on your paper. Don't scratch it out on yours because we're going to need to look at it here in just a moment. But I'm starting with this right here. Remember, we're supposed to make a relationship that's telling me about ABD. How can I make a relationship with ABE and ABD? Is there any other angle in there? DBE. How do we get angle ABE? We can't do a midpoint. B is not a midpoint, because midpoint I just have to have one segment. They add up to 90. How do we know that they add up to 90? Because we've got that red angle is a right angle, right? Well, what are the two angles that we have to put together to get the right angle? The red angle is angle ABE. What angles do we have to put together to get ABE? Yep. Not looking for my reasons yet. I want you to look at the picture. To get ABE, that one outlined in red, what angles do I have to put together to get that? ABD plus DBE. Measurement of angle ABD plus the measurement of angle DBE. Do you guys see that? If I take this one here, ABD, and I add that to this angle right here, DBE, then I get this angle right here, ABE. What are we using to be able to say that? When we do it with a straight line, I take segment this plus segment this equals segment this, and that's my segment addition postulate. What kinds of things are we adding here, though? I'm not adding segments, I'm adding angles. So what would this be? Angle addition postulate. That's my angle addition postulate in action there. All right, I'm going to go back up and look at the picture. We're also supposed to talk about angle EBC. Well, that's this little guy down here. And I also have DBC. DBC is this guy right here. We know he's a right angle. I'm going to totally ignore this for right now. Can I put two angles together and get DBC, just like I did with ABE? What two angles would I put together to get that red one, DBC? DBE and EBC. So the measurement of angle DBC is equal to the measurement of angle DBE plus the measurement of angle EBC. Same reason, that's my angle addition postulate. Okay, so why did I want to say that? How's that going to help me? Do you guys see ABE right here? What did we say is the same size as ABE? ABD plus DBE. If I know that things are equal in value, what can I do? Substitute. I can replace this with ABD plus DBE. So the measurement of angle ABD plus the measurement of angle DBE. I replaced the left-hand side of that red equation. Can I do something similar for the right-hand side? Do I know something that's the same as DBC? What is the same size as DBC? DBE plus ECB. This right here can take the place of the right-hand side. Give myself the room to do that. So I'm going to replace the right-hand side with the measurement of angle DBE plus the measurement of angle EBC. What allows me to make replacements like that? Substitution. Do you guys notice anything interesting about that equation that we just wrote in number 5? They both have DBE. What can I do if both sides have the same exact thing? I can subtract it. So I get the measurement of angle ABD is equal to the measurement of angle EBC. Using what? Subtraction, property of equality. Nicely done. That one was kind of a difficult one. I want to practice some more with the angle addition postulate. We're going to see it in action, how we would use it to solve problems. So let's go look at number 4. How many angles do you guys see in that picture? How many angles total are there in the picture? I see more than 2. I see 3. What are those 3 angles? I see SOT. I see ROT. That's this one right here. And ROS. Do ROS and SOT share a side? Are they adjacent? Yes. So when I put them together, when I take ROS and SOT and I add them together, it gives me what? Not necessarily 180 because it doesn't make a straight line. It makes ROT. When I take the red angle and add it to the green angle, I get that one that I've kind of outlined in blue on the bottom. I get ROT. So the measurement of angle ROS added to the measurement of angle SOT, if I add those 2 angles together, I add their degrees together, it should give me the same number of degrees as ROT. Do we know how big angle ROS is? 4x minus 20 degrees. So I'm going to substitute that in the place of ROS. Do we know how big angle SOT is? 3x plus 14 takes the place of SOT. Be very careful here. Did they tell us how big the measurement of angle ROT is? Did they tell us anywhere how big the measure of angle ROT is? Yes. Where did they tell us that information? Up here at the top. They told me this. So in the place of ROT, I can put 408 minus 11x. I'm going to add that to the picture too. From here all the way around to here is 408 minus 11x degrees. What can I do now? What do I want to do to be able to solve this equation? Let's combine our like terms together. What are the like terms over on the left side that I can combine together? 4x and 3x. What do I get when I combine those together? 7x. Are there any other like terms over there that I can be combining? Negative 20 and positive 14. What is negative 20 plus 14? Negative 6. So 7x minus 6 equals 408 minus 11x. I have all the like terms on the left-hand side collected together. So what should I do now? Add 6 to both sides, and then I also want to do what? Add 11x to both sides. I usually group my x's before I move my constants, so I'm going to add 11x to both sides first, and then I'm going to add 6 to both sides. There's nothing wrong with doing it the other way around. All right, so I would have 18x minus 6 equals 408. Then I'll add 6 to both sides. Again, there's nothing wrong with switching those two steps around. Either way you do it, you should end up with 18x equals what? 414. What would I need to do next to solve for x? What'd you say? Divide by what? 18. We want to get the x isolated, so I leave the x alone, and the piece next to it is what I have to cancel. 414 divided by 18. Does that come out pretty? It does. What is 414 divided by 18? 23. All right, so that was the first thing they asked me to do, solve for x. We just did that. What else am I supposed to be finding here? ROS and SOT. So let's find ROS first. The measurement of angle ROS. How big was ROS again? 4x minus 20, and we just figured out that x is how big? 23. So I have 4 times 23 minus 20. What is 4 times 23? $92. 92 minus 20 would give me what? 72. And since this is an angle, I have the measurement of angle ROS. I'm going to put degrees on this one. I didn't put degrees on x because x is not an angle up here. ROS is an angle. All right, so there's ROS. We still need to find SOT. Measurement of angle SOT. How big was SOT? 3x plus 14. And we know that x is 23, so I have 3 times 23 plus 14. So that's 69 plus 14. And 83. So the measurement of angle SOT is 83 degrees. Very nicely done. Using the angle addition postulate, we were able to figure out the sizes of angles ROS and SOT. Let's go ahead and flip to that third page. This is the last page in this notes packet. They gave us all of the statements. We need to fill in the reasons here. Is that first statement my given information. Is this what they told me up here? No. If it's not my given information, then it has to be coming from the picture. What do you notice about angles 1 and 2? They form a linear pair. They share this side right here, and together they make a line. That means they're a linear pair. What about angles 3 and 4? Also a linear pair. They share this side right here, and together they make this straight angle, this line. What would our reason for that be? Definition of linear pair. Looking at the picture, we said they form a linear pair, and that would be a definition of linear pair. You have to look at the picture to see that. But then down in number 2, they tell me that angle 1 and angle 2 are supplementary. Then they say angle 3 and angle 4 are supplementary. Well, how do we know that angle 1 and angle 2 are supplementary? Linear pair theorem. Angle 3 and angle 4 are supplementary for the same reason. This is our linear pair theorem. What'd you say? Means they add up to 180. And that gets us to our very next statement down here. We know that angle 1 and angle 2 are supplementary. So why am I allowed to say that that means they add up to 180? In statement number 2, all we knew about them was that they were supplementary. Why can I say that means they add up to 180? Definition of supplementary angles. Measurement of angle 1 and angle 2, that's right here. Measurement of angle 3 and angle 4 is right here. Why am I allowed to say that they're equal to each other? Transitive property. Or I could use substitution, because there's equal signs. So transitive property or substitution property. What do you notice about number 5? That's our given information. They waited all the way till down here to use that given information. We never wait that long. How did they use it then? How did they use that given information? Substitute. Instead of angle 3, they replaced it with angle 2, which we can do because they're the same size here. So this is substitution, and this one has to be substitution. What's interesting about statement number 6 now? There's angle 2 on both sides. If I have the exact same thing on both sides, what can I do? Subtract. So subtraction, property of equality. Nicely done. It's weird that they waited so long to use that given information, but everything that they wrote up above did not depend on that given information. It depended on the picture and the relationships that we can make from that picture. I wouldn't say get used to it, but don't be surprised if they've given the reasons and you see it somewhere further down than you would expect. If I was writing this proof, I would have put the given right at the beginning. But it's not, like, when you're doing a proof, does it have to be that way? Not necessarily. Is it safer to put your given first? Yes. All right, let's do the very last problem. We've got angle addition postulate in action again here. What angles can we add together? RST, measurement of angle RST. We can add that to angle TSU. And when we do that, we get what angle? RST plus TSU would give me RSU. Do we know how big angle RST is? 20 degrees. So I'm going to replace the measurement of RST with 20 degrees. Do we know how big angle TSU is? 5x plus 65 degrees. So I'm going to put that in the place over here. 5x plus 65. Do we know how big RSU is? 4x plus 100. So this whole thing is 4x plus 100 degrees. All right, what can I do with it now? Add our like terms. What like terms do we have on the left side that we could combine? 20 and 65. So 5x plus 85 equals 4x plus 100. What should I do next? Subtract. What are we going to subtract? Remember, I want to group all my x's together. Well, we want to group our x's first. 4x. Is it wrong if you subtract 85 first? No. Does it mean that you leave the door open for potential mistakes? Yes. This is why I always group my x's first. What's 5x minus 4x? 1x. So x plus 85 equals 100. At this point, I would subtract 85 on both sides. What is 100 minus 85? Nope. 15. Is that all I was supposed to do in this problem? It says solve for x and then anything else? Find RSU. Well, what was the measurement of angle RSU? 4x plus 100. And we now know that x is how big? 15. So 4 times 15 plus 100. What is 4 times 15? Oh, 60. So 60 plus 100 would give me what for the measurement of angle RSU? 160. 160. This one I put degrees on it because this is an angle. X was not an angle by itself, but RSU is an angle, and so I put degrees on that. Very, very nice work today. On your way in the door, you should have picked up the 3-6 homework. That's due on Wednesday. You guys should start working on that today. Tomorrow with our in-class time, you will be allowed to ask me or work with a partner questions about that homework. And then you'll also have work time on the review for the test on Thursday. I will pass out the review for the test on Thursday. That'll be available for you guys to pick up when you come in tomorrow. So tomorrow is a work day. You need to work on the 3-6 homework before you come in tomorrow so that you don't spend all your time just doing the homework. You have time to ask questions about where you're stuck. So you get that all finished up for Wednesday and then spend the remainder of the time working on the review. We got to reach all the way back in our minds to when we talked about statements, hypothesis, and conclusion. How do we make if-thens? How do we decide if they're true? Writing the converse, the inverse, and the contrapositive, and all that stuff that we studied before we actually started writing our proofs.